So we had the distribution of a coin is chose 3 times, and we have 0, 1, 2, 3, xp of x. Here we have 1 over 8, 3 over 8, 3 over 8, and 1 over 8. So we define the cumulative distribution function as f of x equal to the probability that the random variable is less than or equal to x. So we can now say that this function is equal to 0 if x is less than 0, is equal to 1 over 8 if x is less than or equal to not less than or equal to if 0 is less than or equal to x less than 1, and it is if 1 is less than or equal to x less than 2. Half is 4 over 8, and it is 7 over 8 if 2 is less than or equal to x less than 3, and it is 1 if x is greater than or equal to 3. So we can make it as a distribution. We can make a graph of this distribution this way. 1, 2, 3, 4, 5, 6, 7, 8. Before 0, we have 0. At 0, we have 1 over 8. That goes here. Then at 1, we start with half. Then at 2, we go to 7. At 3, we are at 1. So this is, yes. Let's check what we have. Less than this. We did this already. You did this one now, right? You are just writing this? Okay. So this is what we wrote last time. Yeah. Okay. Yeah. So you should correct that. It wasn't 0. We will say that this is not a function which is not continuous. That's the characteristic of a cumulative function of a discrete distribution. It is not continuous at some point. So now we want to get into the next section, 3.3. Averages. Let's call this averages. So average in probability as it is in statistics is the point from which you want to assume the middle. So when you have your score, for example, you want to know what is the middle. The average helps you to determine your position, if you are performing lower or higher. So we are going to learn for each distribution, what is the average. In general, we have several types of averages. But the one that we use the most in probability, the one that we use often, is the mean. But I'm going to mention the other averages, which we are going to come back to it because they are also useful. The mode is one of the easiest one to find. We call it the mode. The mode is the most common value, or the value with the highest probability. Value with the highest probability. So in the example that we just had, the mode was 1 and 2. There were 2 modes. So the median is a value m such that f of m is equal to half. That is the probability that x is less than or equal to m is half. That is it's at the middle of the distribution of. So the cumulative frequency at the median is half. So 50% of the values are below the median, 50% are above the median. Now we have the mean. The mean is denoted by P of x or mu. This is the Greek letter mu. And E of x is equals to, for a discrete case, is x times P of x. Which is equal to x1, P of x1, plus x2, P of x2, plus xn, P of xn, and it can continue. So for discrete case, we talk more about the mean than the median or the mode. And we may talk about the mode as well. Because especially for finite case, if you want to subdivide the data into half, you may not find it very easy to do that with the median, because with random variables, you will only have maybe, if you have an odd number of values, the middle will be one of the values. Otherwise, the middle will be the average weight of the 2 values that are at the middle. So let's look at some more examples and use those examples to find the mean and the mode and the median. Let me look at example. A die is rolled until you get a number. Let me just say you get 1, to make it simple. You want to roll a die until you get 1. Let X be the number of rolls. Then X equals to 1, 2, 3, 4. Remember, we have this example as an example of infinite, discrete, random variable. Then we define the probability distribution of X as 1/6 times 5/6 raised to power X. You remember this? You remember how we got this probability distribution? Did we do that last time? We said that the probability for 1 is 1/6. That the first time you get number 1. The probability that you failed in the first time and get it the second time, probability that you fail is 5/6 times you get it 1/6. Then probability that you get it the third time is that you fail the first 2 times. So in general, so this is X minus 1, I'm sorry. X minus 1. It is X minus 1 because we are counting the number of rolls. We could also define it like the number of failure. That's what we will do later on. We are going to be talking about the number of failure. And when we define X as the number of failure, if we define X as the number of failure, then we will put X there instead of X minus 1. Now suppose we have this probability distribution, which you understand where it is coming from. Let's find the cumulative distribution of this and the mean. So the cumulative distribution f of X is equal to sum of, I will use K instead of X. K times P of K equals to 1, X. Actually, you know that this is equal to probability that X is less than or equal to X. The probability that X is less than or equal to X is the definition of the cumulative distribution. Do we understand what I mean here, Dasha? Cumulative distribution is sum of everything up to where you are. And that's the meaning of this sum, this expression. You are adding from 1 to, so we can write it again, that f of X is equals to P of 1 plus 2 P of 2 plus 3 P of 3 plus, let's say, X P of X. The probability that k is less than or equals to x. I will write it here again. Probability that x is less than or equals to small x. So we can write this again as sum from k equals to 1 to x k over 6, 5 over 6 raised to power up. No, this is not true. I'm doing the mean instead of the cumulative. And I wanted to do the cumulative. Do you see what I've done? I'm doing the mean. I wanted to do the cumulative first, and I'm doing the mean. What should we do? Complete the cumulative or find the mean? And to change it, I just put this one and this. But let's do the cumulative. Please. Let's do cumulative. So I remove this. I remove this. And I remove this. Please, do we understand? Let's make sure we are understanding what I'm doing here, because we are going to do some little mathematics here. So if you are not following, you might find yourself a little lost. So here we are still at the definition of the cumulative distribution. Okay. So it's the sum of probability, essentially. Sum of the probability. So I can write this as sum. I will take 1 over 6 out. I will take 1 over 6 out. And I will say k equals to 1 to x. 5 over 6 raised to power k minus 1. You already have this. I want to. So that will mean 6 times f of x is equal to sum of 5 over 6 k minus 1, k equals to 1 to x. Do you see what I've done? I've multiplied both sides by 6. Now look at what this is. This is equal to, when k equals to 1, what is the first term when k equals to 1? Please everybody think. When k equals to 1. Do we all see this 1? That is the first term. Daisha, are you with us? I'm sorry if I keep calling you because you have not been in mathematics with me before. So I want to make sure you are with us. Good. So it's not like I'm trying to pick on you. So now we have k equals to 1, we have 1. When k equals to 2, what do we have? Five over 6. When k equals to 3, 5 over 6 squared. We will go like that until when k equals to x. When k equals to x, do we see what we get? It is just the general term when k equals to x. We remove k and put x. Now I will multiply both sides of this equation by 5/6. You will see what I will get. Let me do something else. I will say let A be equal to 1 plus 5/6 plus 5/6 squared plus 5/6 x minus 1. Now I will multiply A by 5/6. Then 5/6 times A will be equal to 5/6 plus 5/6 squared plus 5/6. I will, the first two terms and the last two terms, I'm going to write the first two terms and the last two terms. The first two terms, we have it here. The last two terms, I will shift a little bit for the case x minus 2, then the case x minus 1. Second to the last term is x minus 2, then x minus 1. So when I multiply minus 2 by 5/6, I will have x minus 1. And then 5/6 x. Do we see that? Now I will do a minus 5/6 a. That is the first one minus the second. First expression a minus 1/6a. When I do that, you will see that 5/6 will cancel this. Then this one will cancel this. Then at the end, this will cancel this. Because I'm doing the first row minus the second row. Do we see what I'm doing? That is this one minus this one. A minus 5/6a. Do you see what is left? Can somebody tell me what is left? What is left here? What is this? We are doing up minus bottom. 1 minus 5/6 x. So A is not a very nice expression. Is 5/6 x divided by 1/6. 1 minus 5/6 a divided by 1/6, which is 6 minus 6 5/6 x. So now let's recall what a was. Do you see a here? A is 6 f of x. This is that 6 f of x here. So this is 6 capital F of x. So what do you think is f of x? What do you think is capital F of x? Six times f of x equal to what we have here. So what do we have as f of x? Mason? capital F of x times 6 equals to this. Maggie, help us here. If 6 times f of x equals to what we have here, equals to this, what will be that? Anybody else? What do we get? If we divide this by 6, what do we get? We got a good function. That is capital F of x. Actually, this is how we are supposed to write it. We are supposed to write it as f of x is equals to f of x is equal to 0 if x is less than 1, and it is equals to 1 minus 5 over 6 x if 1 is less than or equals to let me just write if x is greater than or equals to 1. Okay? So this is capital F of x. Let's play around with it. What is the limit of this function as x tends to infinity? Let's start with negative infinity. As x tends to negative infinity, calculus, what is the limit of this function as x tends to negative infinity? Yes. Not 1, negative infinity. If it is positive infinity, it is 1. Okay? Because the limit of 5 over 6 at infinity is 0. The limit of a number between 0 and 1 at infinity will be 0. That works. What about negative infinity? Which one is bigger, negative infinity or negative 3? Which one is bigger between negative infinity and negative 3? Because limit at negative infinity is limit when x becomes extremely small or large in the negative sense, right? So is negative infinity less than 0? Negative infinity is less than 0. Is it less than 1? It is less than 1. Funny questions, right? Now, what did we say when x less than 1? What is f of x? It is? And what is the limit of f of x as x tends to negative infinity? 0, right? This is a property of the cumulative distribution function. And we will have that the limit of f of x as x tends to infinity is equals to 1. Now, suppose I ask you, find the probability that 3 is less than or equals to x less than or equals to 5. What will be the probability that x is less than or equals to 3, less than or equals to 5? it will be P of 3 plus P of 4 plus P of 5. Which is actually f of 5 minus f of 2. Can you see that it's f of 5 minus f of 2? Because f of 5 is P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. This is f of 5. And f of 2 is this 2. The reason why I'm giving you this is that if you have a discrete distribution and I want to know what is the probability that x is maybe greater than 5 and less than 20, you are not going to be doing P of 5 plus P of 6 plus P of 4. You should just use the cumulative function if you know. And with the cumulative function, you are going to take f of 5, that is replacing x by 5, and then replacing x by 2, and take the difference of the two values. Now, let's look at the mean. Let's look at the mean. The mean of x is equal to sum of x times p of x, x going from 1 to infinity. Remember that x was 1, 2, 3, 4, 5 to infinity. P of x is multiply x by the probability of x and add them up. It is a little bit different here. So we can write this again as sum of 1 to infinity. X, P of x is 1 over 6 times 5 over 6 raised to power x minus 1. P of x is sum of x times 1 over 6, 5 over 6, x minus 1, which we can write it again as 1 over 6, sum of x times 5 over 6 raised to power x minus 1. Isn't it? Now, define f of x as sum of define f of x as sum of 5 over 6 x. If we define f of x as this, sum of 5 over 6x, then what will be f prime of x? This starts from 1 to infinity. This is from 1 to infinity. Dasha, you remember derivatives? Derivatives. So when we do xn, the derivative is what? N x minus 1. So x here is standing for our n. Would you mind if I change the x to n so that we understand it easily? Okay, I'm going to do a change here. Look at what I will do here. I will instead write that, I'm sorry, I could leave this one. I will change this a little for us to learn something. You will like it. Let's say let g of x be equal to sum from 1 to infinity of x raised to power n. This will look what we know. What will be g prime of x? Anybody? What is g prime of x? So look at it here. So if we can work with this, we will work with that. Oh, yeah, it's almost time. So do you see what, this is what I will do. If I can get this g of x, then the derivative will give me the one we have up. We will continue this from Friday. Yes, Dasha, you have a question? Yeah, please just try to find out for yourself how to do this sum, mimicking what we did for capital F of x. It looks like what we did for capital F of x to do this one. Find the sum of xn as homework. Sum of the xn from 1 to infinity. Thank you, Maggie. Take care.